Good afternoon, boys and girls. In this video, we're going to look at what we call the formal definition of integrals. And we're going to represent that formal definition using a Riemann sum and limits. So before we begin, what I would like for you to do is I would like for you to pause the video, and I would like for you to read the very first page of this packet. Yes, it's going to require you to read. When I go over it, I am not going over from a detailed point of view. I'm expecting you to get the information you need from the reading, and then afterwards I will show you some examples. So please pause the video and read the very first page of this packet. Welcome back. I'm assuming that you have read this, so please don't ask me any hard questions. What we're going to do today basically is to be able to take an integral and write it in limit notation. So like for derivative, we had the limit notation, we had to recognize it as a derivative. In this, we are going to be given the integral, and we have to recognize it as a limit. And to do that, the most important thing that you read happened in this little paragraph. It's summarized in this paragraph. You should be able to find delta x. You need to be able to find x of a plus k to the x. And then once you find that, your limit representation, we're going to write it in this form. Okay? So that's what we're doing. We're going to find delta x, we're going to find x of k, and then we're going to use both of those to find f of x of kx times delta x, and then write it as a limit. Okay, boys and girls, are you ready? Now, this will probably only be one multiple choice question on the AP exam. And in our class, it probably will be only one multiple choice question on your test. Okay, so it is not heavily tested, but it's that one question, and we want to make sure that we get every question correct. All right, or as many questions as we can. So the first thing we need to do, we're given the integral from 0 to 5 of 4x dx. I know you can all find that integral, but we want to write it as a limit. So the first thing we need to do is we need to find delta x. Okay, so if you recall from the video, from the reading, delta x is equal to b minus a over n. So in this case, b is 5, a is 0. So delta x in our case is 5 minus 0 over n. Okay, so we found the first part of that. We found delta x. And the second thing we need to do is find x of k. So x of k is equal to a plus k delta x. Okay? So what is a? A is our initial point. So in this case, a is 0. Plus k times delta x, which was 5 over n. Okay, then after that, we're going to find f of xk. Well, f of x is 4x. Okay, so then f of x of k, we're going to, every place we see x, we're going to change it to x of k. So that'll be 4 times 5k over n. If we just go ahead and simplify that, 5k over n. Okay? And so now that's all the things that we need to know. And then the last thing is we're just going to write it as a limit. So this limit, as n approaches infinity, of k equals 1 to infinity, is f of xk delta x. Okay? So that would be the limit as n approaches infinity, k equals 1, infinity, and that should be f of xk, sorry. F of xk. I'll erase it so you'll know. I'm sorry, I wrote that wrong. So that's f of xk times delta x. So f of xk is 20k over n. I just multiply 4 times 5 times delta x is 5 over n. Now, we could simplify that if we like, and we can write that as the limit as n approaches infinity, k equals 1 to infinity, and 4 times 5 is 100k over n squared. And so we could write it like that, and this is our answer. That is how we would represent this integral in limit notation. Okay? All right, let's just do a couple of more examples. So example 2, we're starting from 0 to 2. And we have, so the first thing we need to find is delta x. So let's start. I'm just going to keep writing the directions down so we'll remember. We have to find delta x. So delta x is going to equal to 2 minus 0 over n. Okay? And then we have to find x of k. So recall x of k is equal to a plus k times delta x. So we know that a in this case is 0 plus k, and we know delta x is 2 over n. So delta k is equal to 2k over n. Just simplifying that a little bit. Okay? Now we have to find f of x of k. So remember, we're just, f of x is this function. So every place I see x, I replace it with 2k over n. So I now have 2k over n quantity squared plus 10. And that's going to equal to f of x of k. So now, and that is times, so now we're going to take the limit, we're going to go back and take the limit, and remember we write the limit as n approaches infinity of delta k, summation k equals 1 to infinity of f of x of k times delta x. So that would be the limit as n approaches infinity of k equals 1 to infinity, and f of kx is 4k squared, I'm just going to go ahead and multiply that out, over n squared plus 10, and we have to multiply all of that times delta x, which is 2 over n. And again, if you want to simplify that, you can, but I am completely content in leaving it like that. Okay? What I'd like for you to do is I'd like for you to pause the video, and I'd like for you to try problem number 3. Okay? Welcome back, and let's see what I have. So I'm not going to write the steps out again. First, I'm going to find delta x. So delta x is 3 minus 0 over n. X of k is equal to my initial value, 0, plus k times delta x. And then I have to find f of x of k. So every place I see x, I'm going to replace it with x of k. So in that case, that is 5 times 3 over 3k over n squared minus 2 times 3 times 3k over n. which if we simplified that, that would be 945 k squared over n squared minus 6k over n. So then we write that as a summation. So that's going to be the limit as n approaches infinity. K equals 1. Ignore that. Going to infinity. F of kx, which is 45 k squared over n squared minus 6k over n. And I hope that's what you got. And we have to do all of that times delta x. 3 over n. Okay, boys and girls, so I hope you have got that as your answer. On the next few pages are some examples. And I would like for you to try these examples, like here's number 2. And there's the rest of it is just Riemann sum. That's really the only gave you one example of this. So if you can complete the next few pages, and the answers will be on your Google Classroom under Answers and Solutions for this unit. All right, boys and girls, I hope that was helpful. Again, this will only be one question on your test, and probably only one question